Good morning to everybody joining us. We'll just wait a little while till participant numbers have stabilised. Can still see a few people joining, so we'll get kicked off in just a minute. Okay, so good morning, everybody. Welcome to this Recoup webinar. This is the third in a series of webinars that we've held this November. We've got a great lineup of speakers for you today, talking around circularity and sustainability in complex sectors. So before we start, I'm just going to give you a brief overview of Recoup before we move on to the presentations. So Recoup is a charity set up in 1990. We pride ourselves on being a leading authority, providing expertise and guidance to the plastics value chain. We're a member-based organisation and currently have around 160 members. Collaboration with our members is key to delivering our aims and objectives, which you can see up there on the slide. If we go to the next slide, please, Bex. So we have 4 key pillars of our work: policy and infrastructure, packaging, recycling and design, sustainability and circularity, and communication and engagement. Through these, we deliver a number of activities, from reports, you can see a few around the slide there, UK Household Plastics Collection Survey, sorting and infrastructure report, recyclability by design guidelines, and we also can issue certifications based on recycle class and looking at OPRL, as well as activities like our communications platform, Pledge to Recycle, where we engage with the consumer on the messaging around plastics recycling. So on the topic of reports, if we could just go to the next slide, Bex, we do have the launch of our 2021 Household Plastic Collection Survey tomorrow via a webinar again. And we also have another webinar on Thursday around film recycling supply chain opportunities. So if you would like to sign up to either of these, then please visit our website to do so. So before I hand over to our chair today, Stuart Foster, CEO of Recoup, I just want to run through a few housekeeping for today's webinar. So we will not be using the chat function or the raise hand function, but we'll be directing all questions through the Q&A function. So if you have any questions throughout any of the presentations, please pop them into the Q&A function and they will be picked up by Stuart as we go through. This webinar will be recorded and circulated to all attendees after the webinar, and then a version of the slides will also be made available. So with that, I'll hand over to Stuart, who'll be chairing today's session.
Thank you, Catherine, and welcome all to this webinar. It's one that I'm actually really looking forward to. Quite often in plastics, we see the word complex and circularity and sustainability, and we have got a challenge on to try and bring those all together. But it's a challenge that I think more and more groups are stepping up to, and actually we're seeing more and more support for activities in the sector. We know there have been many advances in addressing those challenges, but you know, the complexity is sometimes there for a reason. So what we're going to hear today is some of those opportunities, how we can resolve it, and how we can actually move forward and deliver. Certainly many Recoup members and others within our network are approaching us all the time now about all sorts of different areas, and some of which will be covered today by our excellent group of speakers, which includes University of Manchester, Trinseo, Stuff for Life and Podback. We've got the speakers lined up. They'll have about 10 minutes to share their slides and give us their views. At the end of each speaker, I'll take 5 or so minutes. So yes, please do get your challenges, questions, comments into the Q&A, and I will use those to steer me. And then at the end, depending on time, we will have a wider discussion and see where we get to. So we shall move on to our first speaker. Very, very pleased to welcome Arthur Garforth, Professor of Catalysis at University of Manchester. We've known University of Manchester for quite a few years, but certainly in the last 2 or 3 years, Arthur and I have been having more regular conversations, and there's a lot going on in this space. So Arthur, over to you.
Thank you very much, Stuart. Very kind introduction, and hello to everybody this morning. First slide, please. So I'm hopefully going to talk to you, and thanks for the invitation, about a couple of case studies and some thoughts around how to start to tackle this issue of recycling problematic polymer composites. Next slide, please. So we're all familiar with the circular economy. Thank you, Bex. And I particularly started my work in this area about 30 years ago, looking at municipal packaging waste, and of course doing the obvious thing, as you see from the 6 there, of looking at pure polymers and then starting to mix them up. But just for reference, the UK processed around 4 million tonnes of virgin and recyclate in 2018, of which 40% was food and non-food packaging, and of that, a quarter was roughly these difficult things called flexible packaging materials and laminates. They're difficult to sort, they're difficult to collect, and therefore we need new technology to divert them away from landfill and incineration. Next slide, please, Bex. So here's one example. If you start off with how we get the polymers in the first instance, we distill them, we generate CO2, we generate these things, petrochemical intermediates. They go to our favorite polymers. If you're talking about ethylene and propylene, that's obvious, and paraxylene going into PET, and they end up in the bin. So if you could sprinkle some magic powder, then you could do a process which is well known to big oil and gas, which is hydrocracking or hydrotreating, and you'd be able to convert those into LPG, naphtha, and something like jet kerosene. And that's published there. Next slide, please. So I was involved, pardon me, I was involved in a recycling project that started to get me interested in this area, and I knew no one. So it's a good place to start. And I was put in contact with people, and we built a package which was a 1-year project which looked at blister packs and involved the various people you see there. Rosie Barker is taking up the baton for Manchester University NHS Foundation Trust, and Mike Clues being the Axiom and Recomed continuance working with Recoup. But all the rest of the people there were not known to me until we started this project. And you can see it's a fair array of stakeholders, and a big thank you to Adrian Wild at the bottom there for putting us in contact with lots of people. The package was 3 things: a bit of science, trying to figure out how to map using a systems approach things through a hospital system, which is difficult, and that work is continuing with Recoup. And also what we do might not actually be of any benefit, so a bit of Lca analysis. Next slide, please. So not to get too techie on the audience, but basically to say blister packs and the simple, humble tablet pack, which I have in my hand here, is a complex item, but it's also one of those things that we can easily identify. So thoughts on collecting it might be through pharmacies, for example, and care homes, nursing homes, and that sort of thing. But it's a complex sandwich. And if you look at the middle picture, you can see it's polyamides glued to aluminium, glued to PVC. And what we did with a bit of thinking about it and very good links with AstraZeneca through Nigel, we're able to separate that into 3 parts. The blackened PVC I'll explain in a second. Next slide, please. So a little bit sciencey, I appreciate, but basically going from the top to the bottom, ionic liquids are things which are molten salts at room temperature. So if you took your salt that you put on fish and chips, then to heat that, to get it molten, would be 800 plus degrees. It's a high temperature. These things are room temperature and they're not very volatile, so they're quite stable things. Going from the top to the bottom, you can see a color change, and as you go down, you're changing, basically keeping the cation the same, but the anion is changing. So it's going from something that's sounding nasty, BF4 minus, all the way down to an acetate ion, not so nasty if we think about vinegar and acetic acid. So at the bottom, you were seeing that we're stripping out HCl, and in the process of doing that, we got the orientated polyamide, sorry for the thing flipping there, aluminium and a polyene, which is a HCl removed polymer backbone. Next slide, please. So to improve the circularity, Bex will now make it all animate, that's it, thank you. So we're able to take the PVC, separate it out into a polyene and HCl. The formatting's gone a bit wonky there, but never mind. And by mixing it with packaging such as LDPE and PP, so the secondary and tertiary packaging, it's a hydrogen source effectively. You can give hydrogen to the polyene and you can crack it and get LPG and naphtha, which we've done. The slide at the top gives you an idea of the sort of products that you can get at depending on conditions, but gas, gasoline and diesel are equivalently LPG, naphtha, and going towards kerosene. Now, the key thing about that is naphtha can be cracked, steam cracked, and turned into ethylene and propylene, which can then be turned back into polymers. You can also take the HCl that we've separated from the PVC blister pack and adding it to ethylene, go back to vinyl chloride. So we've got two closing of the loops in that scenario. Next slide, please. Now, one of the things that's often talked about, and I've heard arguments about it, discussions about it, heated debate, if you would, about mechanical and chemical recycling. Both mechanical and chemical recycling have roles to play. They are bedfellows. They are not at war with each other. They're not competing technologies. Mechanical will allow you to recycle material a number of times, but generally to a lower grade of material. Chemical recycling is attempting to keep the value of the polymers intact. So you can effectively take the polymer to monomer and chemicals and turn it back into polymers as well as something else. Here you've got Andreas, who gave a presentation at a conference that I was organizing in Manchester a year or so ago. It was virtual, of course, and he showed some data. This one I've just picked up on CO2, where you're comparing incineration against mechanical recycling and pyrolysis. Pyrolysis being a chemical recycling technology. And you can see they're about the same, but they're both much better than incineration, which is what you would hope for and what should be. Next slide. So some thoughts moving forward, because my time is short. Lots of things are always said here that are barriers put in place. So I'm going to list them as common things, and these are the things that people are now addressing. So you've got collection, sorting, and in the case of clinical or medical waste, you've got decontamination. You need a quality of feedstock and a quantity of feedstock. So the things that I've shown you there, big oil and gas, big chemical companies, big polymer companies have access to equipment on a large scale that would allow you to deal with these materials, but you've got to have a guaranteed feedstock and you've got to have enough. So one of the ways that this is being tracked or being led towards is by trying to create a specification on oxygen, chlorine, sulfur, and metals, for example. The solid recovered fuels, the CEN class 1 is a good idea because that gives you a chlorine content, it gives you a minimum calorific value. But all it is trying to do is if we're doing a chemical catalytic route, we've got to stop poisoning the catalyst. If we're just doing a thermal route, we've got to stop destroying our reactors and our pipes by generating gases which are acidic and also dangerous. And we've got to stop any chlorine and other halogens, for example, transferring into the product and therefore contaminating any oils that we've got, which then if they are used as a source of fuel or some other process, they're going to have contaminants in. Next slide, please. So there's a need for legislation, but also what's allowed in packaging. So, and where is that? If we think of plastic to plastic, where's the certification coming for recycled content? Well, a lot of talk around a mass balance approach. So how much we put in is measured. So if it's 30% recycled, it's measured how much is put in. But is that sufficient to prove the chain of custody? Also, is it sufficient to prove that the final product contains that amount of polymer? So there's lots of work going on in that area with markers as well as other things. In the area of recycling itself, I'm just checking myself for time, there are new technologies. There's the big technologies such as gasification to syngas. Syngas is CO and hydrogen. CO and hydrogen can be converted into fuels using Fischer-Tropsch process, a long established technology. But also syngas, CO and hydrogen can make methanol. Methanol can be converted into olefins, established processes there in oil and gas for sure. And then olefins can of course go back to polyolefins. There are now the new entrepreneurial companies that have set up that are doing interesting things. So on a hydrothermal basis, Renew ELP, on a fluidized bed type technology and pyrolysis technology, you've got recycling technologies and plastic energies. What I'm trying to get across there, and I think I've said it once already, is you've got mixed economies of scale. You've got both smaller investigative companies setting up, showing the way forward with innovation in technology, and you've got established technologies which are large scale, but again, they need the content. Next slide, please. So what I've learned so far is you need a systems approach to look at flows in and through and out of a system, identify the key stakeholders, look for designer solutions if you can. Look for easy wins first. I'm thinking of blister packs. I'm thinking of shop floor scraps, which are basically high grade pharma. 10% might be failing before it goes to a product that can be recycled. So look for examples where you can start to test the technology. Multidisciplinary teams. Most importantly, though, a willingness to share. We got a long way working with Nigel Budgeon at AstraZeneca, for example. Our NHS colleagues were fantastic on sharing information with us, and Duncan Flack at Livio Research was also very, very kind with his time and technology to help us decouple PVDC, PVC, and the polyolefins that might be with it. Last slide, next. So in conclusion, I've said most of this already. Some plastic waste doesn't always need separating. Our work was on mixed polyolefins with slight contamination. You've got composites, complex materials. You need to look for particular options, but I think the key message for this slide is industry/academic collaboration is critical in delivering research impacts and allowing you to go up that technology readiness level from an idea through to working on real materials through to actually designing solutions. So it's then finally, I think funding schemes help foster partnerships, and the NHS in particular has set its own targets and got drivers now to work with that. And they are indeed working with organizations like ourselves and Recoup. And thank you very much for listening.
Thank you, Arthur. I noticed you apologized for it being a little bit sciencey, but actually a lot of people who are non-scientists in the sector do need to understand this. And I think maybe you can become the Brian Cox of the sector and explain it to us in a sensible way, but actually the science is a very important part of this, I appreciate. So the initial feeling from the medical sector then is that we're looking, or you're looking at solutions that deal with what's there rather than trying to redesign the product. There are solutions for some of those complex products that are coming through. Is that fair?
I think that's fair. I think that's fair. I mean, I hold up the well-known and infamous mask that we're all wearing and saying that's an example of what has a simple solution and also what could have maybe a better outcome. So the Sterimelt idea, whereby you're putting this material, you're heating it up and making it into a block, and then it's going to another processor to chip, and then those chips can then be polymerized into products, is an interesting one. We've actually tested this material. It's very very easy to convert into LPG. It's a little bit too easy, in fact, and we can also take it into naphtha. It's one of those things. So if you're thinking about curtains around hospitals and things like that, so that's an easy win. And by diverting it and showing that there's a mechanical way of recycling, that gives us time then to find ways of doing a chemical solution. To be a little bit more specific on your point, I picked the blister packs. We also were going to try and do IV bags, but that became problematic, partly because of information exchange and also time. But yeah, you've got to look for low-hanging fruit first, of course. Look for things that you say, well, this is impossible to recycle, but we really need it. It's made up of 7 layers. How do we separate? Well, you're going to need some science there. We're going to need to look at it. And we're going to have that willingness to share with a partner, which could be under NDA or confidentiality to start with, to try and work out how you might split it back into its individual parts. Does that make sense, Stuart? I'm sorry.
Absolutely, yeah, absolutely. And just a reminder to the audience, if you want to ask any questions of Arthur or anybody else, please do get them in the Q&A. There is a question that's come up from Alex asking, is the method that you've trialed for blister packs energy intensive?
That is interesting, because it's energy intensity is how you look at it. If you were to steam crack your naphtha and turn it back into the olefins, that would be classed as highly energy intensive. We were doing this at fairly low temperatures. So if you're thinking about a standard conversion process of pyrolysis or of hydrocracking, you're somewhere between 300 and 330 to about 500, 550 degrees C. So that's quite energy intensive. We were trying to do this with effectively fancy salts, which allow you to do it between 90 degrees and 150 degrees centigrade. So it's a much lower, and remember, we're not breaking it down as such there. We were separating layers and trying to recapture them. The big success was, and no surprise, was the aluminium separating away from the other layers. But what we didn't expect was to get such a perfect polyamide back out of it as well. So that was quite nice. We even got the glue, but so not that energy intensive compared to heating it up and cracking it into smaller molecules, for example.
Okay, and just a point of clarification, when you were looking at quality and spec of feedstock, were you talking specifically about the medical sector, or is this intended to be feedstocks that then are broadened out beyond just the medical sector?
No, I was being very broad there, Stuart. Sorry. So if we were, I mean, to be able to so that's another very good question. So to be able to get commercial viability and the ability to do it on a large scale, you'd have to have some kind of specification for the material going in. In other words, it's no good saying, oh, I could take out polyolefins, PVC, PET, polyamide and so on. You might get slippage, you might get a little bit. So you need to set some kind of basic standard. And on an oil refinery, it was well known that they didn't want to tolerate any chlorine above 0.5% back in the 1990s. But this specification is a general specification. It's basically setting a chlorine level, it's setting a calorific value, so it should have a certain megajoules, for example, per kilogram. And I was just putting it up as a suggested, or has been suggested to me as well, route of having a quality spec for the feedstock that these companies that are trying to recycle, that have set up, as well as the big companies, know what they're getting, and that you can align to it and know that you've only got 0.2% chlorine or less, for example.
Okay, so are you fairly confident? You used the word difficult quite a few times at the start, but it sounds doable. Are you confident that that innovation is going to come through to deal with these challenges now, and it will become commercialized? And what kind of timescale? What kind of timescale do you feel that will be?
Okay, so that been asked that a long time ago on Radio 4. When do you think plastic recycling will come? And I gave them a 10-year horizon. That was back in 1998. So I was a bit out there. So I'm loath to give you a timescale. What I would say is there will be solutions to things that are currently available to help increase the amount of recycling. I don't think there'll be a magic bullet to fix everything. I think we'll need to look at things in a case by case, which makes it bitty, which makes potentially it time consuming. And that's why I tried to lump all polyolefins together. So for example, you don't need to separate polystyrene, polypropylene and polyethylene. You can lump them together and a process can deal with it. So I think that's possibly this lumping approach might, first of all, identify what you've got. But yeah, I do think solutions are out there, Stuart. I do think the pace of change is increasing. And I do think the innovations, in particular by using hydrothermal treatment, difficult as it is, and the pyrolysis has told the industry where problems are. And therefore, you need to say, well, let's clean it up before we go to recycle it. And then, of course, the foresight to start thinking about redesigning stuff, but making sure that the redesigned stuff is actually good for recycling. I think that's really key. If you're going to change something, make sure there's no unintended consequences, and that's actually worse for you. Like scrapping PVC all wholesale when you haven't necessarily got a very good replacement for it is not particularly a good idea, in my view.
Thanks, Arthur. And one final question, if I could have a 1 or 2 sentence answer, that would be great. Julianne asked, what companies, in your opinion, are leaders in this space, looking and innovating on these solutions?
Well, that's a very good question. Of course, now I have to start saying, well, I can't talk about certain things, but allowing for the fact that I think the technologies out there, from the ones I mentioned on the start, on the companies that are receiving grants, I think that those companies deserve much applause and continued support, in my opinion. And I think you see a lot of talk now of collaborations. So I mentioned a couple with BASF, SABIC, BP, forming strategic alliances. I know there's an alliance in, I think BP and Johnson and Matthey looking at Fischer-Tropsch catalysts. So that helps you turn synthesis gas. So they're not the traditional people you would have thought, but that allows you to turn synthesis gas, which comes from gasification, into useful chemicals. So it really is, I think there's a lot of memorandum of understanding. I think there's a lot of pairing up, but there are sensible things. There's one in Germany where I think it's SABIC and BP have both partnered. I can't think of the name of the place it is, I apologize, but I think that was just recently in the news. So I think there's a lot more of both large and small company involvement.
Lovely.
Not really answering a question, I'm terribly sorry.
No, that was well dodged, Arthur, but that's fine, that's fine. And I think it's fair to say, as I said, there are quite a lot of innovations going on at the minute from quite a lot of companies. Right, thank you very much, Arthur. We will come back to you at the discussion at the end. And there are some questions that will be for the whole group at the end, particularly around the complex packaging versus redesign. So thank you, Arthur. We'll see you later.
Thank you.
Next up, very pleased to introduce John Twitchen, who is the founder of Stuff for Life. Again, somebody who I've known for many years and is often working on innovative activities. So really interested to hear about Stuff for Life. Over to you, John.
Thanks very much, Stuart. Thanks for inviting me. Thanks for having us here. And yeah, we'll crack on. So I guess just a couple of points of challenge, really. I think, you know, we're talking about complex stuff. I think we'll get into some of the reasons for the complexity. Arthur's touched on a few of those already. But it's kind of a sort of question. I think we make it complex, or more complex than it needs to be sometimes. And then just in terms of, you know, achieving circularity in a number of sectors still needs to get there. Obviously, I think pretty much everything we do need, you know, still has got work to do to get to that circularity point. But obviously, I'm going to talk today about a couple of specific things and one in detail. So textiles specifically, and within that, a subset really of workwear. And we're also doing some stuff around artificial grass. So I mentioned that now just in passing, and we can maybe pick it up in discussion. So Bex, if you could move on to the next slide. Our mission is relatively simple. It's certainly easy to write down anyway, to establish, as it says here, an onshore UK onshore supply chain and crack on with these closed loop recycling systems for polymers. But I think it goes further than that. If we're really serious about this, it's actually about a different way of thinking about what we do and how we do it as an economy, as a society, and as a bunch of people involved in various supply chains. So, you know, you've got to look at ownership models, you've got to look at servitization, and really making sure that stuff is fit for purpose and comes back. So next slide, please, Bex, thanks. So how did we get here? Where did it start? There was a high-vis in the gutter on the side of the road. You might see them from time to time, or the hard shoulder of a motorway is another place you see them. Probably been tied to a ladder. The end of its life was flapping away in the breeze, making sure no one drove into the back of the ladder, and then it ended up in the hard shoulder. And I just wondered where these things go. As many of you probably know, I've been involved in the waste resources, renewable energy sector for 25 plus years now, and so is my business partner Miles, who was at Aggregate Industries with responsibility for safety and environment. So you know, very front and centre of both our minds this. And I guess really, you know, it is a complex product. I'd say there's three things to that. The first complexity is that it's a global supply chain and it's linear by design. Secondly, there is a mix of materials used there, which we'll maybe get into in a bit more detail in a minute, but you can see, obviously there's one or two materials there. There's a label, there's the high-vis banding, which has got glass beads in it, and there's a lot of pigment for safety purposes. So, you know, by design and by necessity, it's complex. So another reason to think about this and to talk about this and to focus on it. But thirdly, you know, as I say, it's really a, you know, very good reason that it is, you know, complex like that in terms of performance. But also there's a lack of infrastructure. And really, I suppose a challenge point is price versus value, or cost versus value. You know, and for 20 years, you know, the procurement department has been saying sharpen your pencils, but at what cost? So the prices come down, but at what cost, environmentally, socially, and in terms of infrastructure and understanding, you know, end of life. So we're, you know, there's a lot of things to fix there, but actually I don't think they're that complicated. So as I say, why high-vis? Because it's essential. It's in a high wear environment. I think, you know, looking at polyester material, particularly fabrics more broadly, you know, in a sort of fast fashion sense, or even in a high street fashion, you know, more broadly sort of sense, you could challenge, you know, the quality, you could challenge your longevity, you could even challenge need. But I think, you know, we'd all agree in this space in terms of workwear, you know, it's serving multiple purposes, and its main aim is to keep people safe. So these are the ones, if you can see that, that we were testing on. So if we can move to the next slide, please, that would be great. This is just briefly to bridge to that next point, you know, making some of those key issues, writing them down for you really there, I suppose. You know, in terms of manufacturing use, there's quite a lot of material. It's not the biggest amount, there's 16,000 tons of this stuff. And you might shred it, but it takes up quite a lot of space when you move it around. Yeah, it's quite a lot of material to be focusing on there at the moment. There's a lot in flight, obviously, so that's a per annum sort of sold in, if you like, figure. In terms of the material, already I've said it's composite, linear, and there's limited, although there are some very good examples, there's limited washing and laundry systems in place, but there are some very, very good examples of that, which a lot of companies already bought into for very good reasons. There's hardly any infrastructure. Basically, it goes in a hole or up a chimney, one way or another, particularly polyester. There is some for cotton, but once it's mixed, it's actually quite challenging and difficult. So we can come back to that in questions, perhaps. And there's not actually a lot of manufacturing capacity for polyester fabric in the UK, if any. It's sort of cottage industry level. Most of the polyester manufacture in the UK is going into packaging, which is great, obviously, for Recoup's kind of, you know, mainstay, if you like. But polyester into fabric is really limited. And of course, those externalities that I've talked about, which are really coming into very sharp focus now, you know, particularly in terms of modern slavery, in terms of the environmental impact, and obviously there's an EPR process, or start of an EPR process going on. So the next slide, please, Bex. So anyone can draw a circle or a wheel, and it's frustrated me, I'm sure it has many of you, for the last probably nearly 10 years now, maybe longer, people drawing wheels but not actually doing anything about it.
I think we just lost John for a second, yeah, so we'll just give him a second to tune back in. If you just bear with us. Just while we're waiting for John to come back in, assuming it's not my laptop, Arthur, Rick, are you there?
Yeah.
Just an interesting point that John mentioned around this whole issue of
Sorry, Stuart. Am I back?
no, oh, sorry, John, that's fine, you're back, that's fine, you continue.
I'm so sorry, I don't know what happened there, other than the vagaries of Wi-Fi, but can you hear me now?
Yeah, absolutely, please carry on.
Great, sorry. I was saying anyone can draw a wheel, and it's driven me mad for the last 10 years that no one does much about the wheel once they've drawn it. So this is what we're doing, basically. But it's about a lot more than recycling, as I think Arthur was talking about previously. So the you know, can it be reused? Can it be refurbished? And the redesign piece as well is absolutely essential. But of course, so our first question when stuff arrives with us is, why is it here? We work backwards from there, basically. So I'm really conscious of time, so I'm going to push on. So Bex, could you put the next Slide up, please. Thanks very much. So what we're doing is doing it. And what we're also realistic about, and my past sort of previous life, I was working at London Remade even before RAP was born, actually, working on market development. We know that we need to get the process working without it being perfect. So it's doing better, but not necessarily perfect. And that perfect, or that better before perfect, looks like turning the stuff that we've got into something useful before we turn it into the same thing again. So ultimately, we're working around an offset, if you like, or a sort of credit-based system, I suppose, really, evidencing the process so that we can then hopefully but what we can definitely do is recycle this stuff. So the next slide will show you what we've been up to. So 2 processes there. I'm not the chemist, by the way. I'll revert to Arthur and other people. But what this is showing is 2 processes. So in the top, glycolysis, in that first box there, you can see these. So this is one of the BMX team that I run, one of our race shirts. It's made out of polyester, and that's chopped up in that first picture there. Goes through a glycolysis process to produce a material called BHET, which is goes back into PET manufacture. And the bottom line, which is where we're focusing now, is hydrolysis. So you can see these chopped up in that jar there. And we're just in the process now of upscaling with CPI, one of the institutes in the Northeast, and working with Teesside University on this. We're going from 500 mil through a scale up. We're about to start with a 50 litre process. So it's all getting rather real, literally as we speak. And of course, hydrolysis is a relatively non-aggressive, low temperature process. So, you know, again, we're working at sort of 90 degrees. It's very much using, you know, that sort of natural decomposition, if I can use that phrase, not that it's a biomaterial at all, but it's using a very simple process to break it down. And we've actually recovered the glass beads as well, because they remain intact. They're not affected by the process. So that's really good. And pigment is what we're going to mine.
I think the Wi-Fi bugs might have crept back in. Can I suggest that? Hi, John.
Sorry, am I back?
You are back. What we'll do, we'll give it one more go, and then if you do break off, we'll move on to the next speaker. But yeah, please do carry on. Fair
enough. Next slide, please. So that's just the kit we're buying. If you move on to the next one, I hate Wi-Fi. So this is really the next steps. We've got to really work hard on the carbon impact and the cost, but actually the carbon intensity is much lower by chemically recycling these materials. And I think, you know, there's a real opportunity as well, positively, to engage the entire workforce and really tackle some social as well as environmental impacts of polyester fabric and workwear as a subset. Next slide, please, and then that's penultimate slide. So I wrote an article about this. There was a piece talking about turning bottles into garments, being downcycling, and used some fairly harsh language. So I've responded to that on the basis that actually you can recycle garments at the end. There's not a lot of infrastructure, and we're working on it. But I think, you know, we've got a lot of issues to overcome, I suppose, with the perception of plastics at the moment. Again, Arthur alluded to that. What are you going to replace with? What are the impacts of what you replace with? And being realistic about that. So yeah, last slide, which I think is just contact details. So thanks for your time. I'm really sorry about the connection. But yeah, any questions, Stu?
Brilliant presentation. Thanks, John. Don't apologise for the Wi-Fi. I think very few people haven't suffered from it in the last 18 months at some stage. The first thing that comes to mind for me is actually it feels like a lot of these kind of durable, longer life products, clothing included, have kind of escaped the environmental spotlight over the last decade. it's fair to say, and given what you're doing, the kind of time is right to get this sorted out, isn't it?
Yeah, absolutely. And I think what we're really doing, I suppose, is working out where the playing field is, where the bars might be on that playing field, so that there's a sensible discussion around producer responsibility. I didn't mention in the process there, we're working with ARCO on the scale up. So CPI are helping in the technical side. Teesside University are hosting our circular economy activities. And ARCO are effectively funding. So they're our partner. And they're obviously a big workwear supplier. So they have a lot of polyester in play. And yeah, you're absolutely right. Outcome from the work that you and many others have done in terms of packaging EPR has really helped, because I think it's fair. My view is that for 20 years, we really struggled with a system that didn't work very well. But we can learn now from where we've, I think, got to or about to get to in terms of accepting the liability, understanding what will move things on, and particularly taking into account single use, minimum recycled content, and taxes and levies and charges to get things going. So those things for me work very, very well. But we need to know, as I say, where the playing field is and how high the bars could and should be. So I think that's what we're really doing, Stuart.
Thanks, John. And I specifically set off on this webinar today not to be the one to raise policy, but yeah, absolutely, it's going to play an important role. And actually, we're looking for policy beyond the packaging and helping move forward. One other point, I have to pick you up on it. Anyone can draw a wheel, couldn't agree more. But in terms of the doing, it was a particularly nice wheel. In terms of, again, your kind of time frames, because this is still quite new, are you expecting in the next year to 2 years we're going to see a lot of progress, or is it going to need more innovation beyond what you've got at the minute?
It will need more innovation, particularly in terms of cost and energy and scale. But I think the biggest issue at the moment, not a barrier, it's just an issue, is the focus of everyone involved in plastics is on packaging, and actually we need some focus on other things. So particularly clothing. So all the polyester manufacturing or PET manufacturing is obviously going into packaging. So that entire supply chain in the UK is focused on that outcome, and I completely understand why. But we do need to be testing and trialing and really understanding the flow of contacts. So that's quite tricky because everything's very big and highly geared and really well thought through and optimized over 70 years. All those sorts of things kind of play against a couple of guys with a chemistry set. So I think that's a sort of reality check, really. We're going to need to spend some time on that, because otherwise we'll find ourselves miles behind the world rather than potentially in front.
Perfect. Thank you for that, John. And we will come back to you at the end with a few more questions, but we need to move on.
Cheers.
Next up, we have Julian Renvoir from Trinsio. Julian, are you with us?
I am.
Perfect. So we have worked with Trinsio, particularly over the last year. And again, when we talk about complexities and challenges, styrene is one of those areas, whether it's trade EPS, whether it's consumer products, is something that's needed to be moved forward. And actually, Trinsio have been a very useful source of information for us in where the direction is heading. So I will now hand over to Julian, who's the Global Plastic Circularity Manager at Trinsio.
Thank you very much, Stuart. Do you mind if I'm taking the control of the slides, or just for the sake of space? No issue from your side?
I think if you want to, I think, or you can wave or just say slide, move on.
Okay, let's do that. So thank you everybody for and especially Recoup for giving me the opportunity to discuss about a unique material, actually, although it has been facing quite some headwinds over the past few years, especially on the UK territory. But actually, this material has quite unique characteristics. And it has also a very simple chemistry that actually potentially enable it to become one of the best circular material we can have in the plastics industry. So what I would like to tell you is about the story, the circular story, journey of this material over the past, what we have been achieved over the past 2 to 3 years. Next slide. You can click probably multiple times just to make all the information appearing. What I would like to probably to start with this story is to introduce one of the characters which has been very much engaged to make this material circular. It's Trinio, my company. We are a sustainable material solution provider. So what you can see on the top left, we do offer quite a diverse range of different materials from styrenics, ABS, SIN, but obviously polystyrene. We do have polycarbonates, elastomers, TP, TPU, PMMA with the recent acquisition of Arkema PMMA business, and we do have also latex and binders, covering very diverse range of different type of markets. We do believe in science to bring innovation, and we've got within our vision at least 3 purposes, which is obviously targeting on climate change, environmental protection, and resource protection. In order to materialize this vision, we have set for ourselves 15 sustainability corporate goals, which are segregated into 5 categories, which are shown here. Climate change, sustainable product portfolio, our suppliers, our operation, and obviously, without forgetting our workforce. This presentation will focus essentially on the category sustainable product portfolio. We've got a target by 2030 to convert our product mix toward 40% being sustainably advantaged products. Next slide. And just to give a feel about this important player in the plastic field, so we are present all over the world, 26 manufacturing sites, $3 billion revenue generated, and obviously everything cannot happen with the great contribution of the 3,800 people. Next slide. Can you click? Yeah. Thank you. So what you can see here on this slide is basically the typical packaging value chain, starting bottom left with the resources, oil and gas, and which is going through the different chemical steps from refinery to cracking to polymerization to produce a final item. And here I'm taking the example of a yogurt cup. This yogurt cup, when used, will be disposed, best case scenario for our story, in the plastic selective collection, the blue bag, the yellow bin, depending of the place you are locating in. It will find its way to the sorting center, might be sorted depending on the material, the sorting center capabilities, etc., to find its way to the recyclers. Today, around 95% of plastics are mechanically recycled, which is very fine, but we know also there is some limitation around the standard mechanical recycling process. Limitation in terms of recycling cycle, complexity to handle complex system when polymers are blended, additivated, contaminated. So the industry came with different options to recycle this more complex type of system. When it comes to polystyrene, there is 3 systems which are working pretty well, which are under development and also reaching the commercial stage actually. The first one is a super clean mechanical recycling process. So it's standard mechanical recycling, but you add a purification step under extrusion and degassing system to boost the quality of the recyclates. When it comes to polystyrene, you can reach 99.9% purity. So basically opening the realms of the food packaging applications. That's good, but with this system, you cannot tackle the whole range of waste. So the industry came with another option, which is dissolution. Dissolution, you are using a solvent to extract the contaminants from the polymer without touching, changing the polymer structure. So even from an energy standpoint, and as such an LCA standpoint, that's quite positive, encouraging. And we do have some commercial option already available for polystyrene, with the polystyrene containing 30% post-consumer recycled content. It's not food approved yet as per EFSA, but the quality of this material does allow to be used in sandwich structure, 3-layer structure, where you include the recyclates between 2 virgin layers. Third option, depolymerization. There is not so many polymer actually which can be depolymerized, which means using temperature and pressure to go from the polymers back to its building block, the monomer. Actually, you can do that with PET, with polyamide. PMMA as well works pretty well, and obviously our dear polystyrene. The last one, which I cannot miss to mention, is the feedstock recycling. This is also a chemical recycling process, which is used basically, essentially for polyolefin, P and PP. But actually, this route, you can also produce from mixed plastic waste using high temperature and pressure, going back to fuel. And this fuel needs to basically reach again the cracking step to reproduce the different intermediate chemicals, ethylene, propylene, but also benzene. The benzene is an important building block to reproduce styrene. So actually, it's another route to produce recycled styrene and as such, recycled polystyrene. So the key message here is, thanks to the simple chemistry of polystyrene, actually, you can use different routes to recycle this material. Next slide. So I'm talking about circular polystyrene. Actually, there is another option also to have a circular polystyrene, which is a bio-waste source polystyrene. So what we are using here is bio-waste. So it could be used kitchen oil, could be residues from the pulp industry, forestry residues, agricultural residues. These are waste. We are converting this waste into a bio-naphtha type of, blending that with a fossil-based naphtha within a cracker, and you can produce styrene, which will be used to produce biopolystyrene using the mass balance type of approach to enable providing solutions to our customers and the brands, sustainable ones. Next slide. I will not dive into an explanation about the mass balance concept within 10 minutes, mission impossible, but what I can tell you, at least, is this system allows to allocate a certain quantity of sustainable feedstock, which has been introduced in the value chain, somewhere in the value chain, and to allocate this quantity to a final product. This is what we call virtual allocation. The best analogy that we can speak of is green electricity. So today, there is not enough sustainable material available to dedicate assets and keep separate the biostreams from the fossil-based streams. So what we are doing is blending. But as soon as you blend biofeed with fossil-based feed in a continuous process with a different quantity for each of the streams, then you lose precise tracking, physical tracking of the biostream. Nonetheless, thanks to the mass balance, the virtual allocation, we can still allocate a certain quantity of feed to the final product. The interesting aspect of the mass balance concept is at the end of the day, you've got a virgin-like type of product. So it's a drop-in solution. So which means that basically today, you can provide sustainable solution to the customers and brand owners without having to requalify, redo testing of the material. Next slide, please. Now, an interesting way also to show that recycling polystyrene is ecologically viable and providing some positive environmental impact is to use a tool that we call a life cycle assessment. There is a consortium which has been created 3 years ago called Styrenic Circular Solution, gathering predominantly converters, equipment providers like Tomra, and some other important player on the packaging value chain, which has been generating a life cycle analysis for the three different recycling technology I was mentioning, the super clean one, the dissolution one, and the depot one. What you can see on the right part of the slides, the green bar, is basically providing an indication about the carbon emission reduction that you can expect recycling polystyrene through these different technologies. Obviously, you can see that, no surprise, mechanical recycling behaves better, but actually the difference between the different technologies are not that pronounced. It has to do notably when you take into account the yield, the respective yield of each of these different technologies. Next slide. Very important. Actually, the recycling of polystyrene is not just a story or test done in a lab. This is commercially available today. Notably, and you can see that on the top left, there is an asset in the US on the West Coast belonging to a company called Regenix, which is a JV between Agilix, a technological provider, and American Styrenics, a PS Redesign suppliers, who has set an asset which with nameplate capacity to convert 3,000 tons of polystyrene waste back to recycled styrene. This is operational for a couple of years now, and we are using this material to provide to the market already chemically recycled polystyrene. Now, even more important, in Europe, there is 4 initiatives going on to depolymerize polystyrene waste back to recycled styrene. There is 2 in Belgium, one from Indaver, a leading recycler in Belgium, that will have an asset operational by 2023. We do have an asset also in France. This is supported by Ineos that will convert 15,000 tons of PS waste back into recycled styrene, operational around 2025. Trinseo, we do have our own project to set up an asset in Belgium, converting the same capacity, 15,000 tons of PS waste back into recycled styrene. And we plan to be operational by end of 2023. And last, not least, Michelin, the famous tire brand, has also decided to invest into a new sustainable chemistry, and they will convert around 20 kilotons of PS waste back to recycled styrene for their captive demand, but they will also sell this material for other type of application beyond tire, operational around 2023. If you take a look at the number in the middle, by 2025, based on depolymerization, we do expect to have more than 40,000 tons of recycled styrene via this means. Now, if you take into consideration the other technology, the solution, superclean mechanical recycling, feedstock recycling, we estimate to have available around 150,000 tons of recycled polystyrene by 2025. Next slide. Now, I just would like to mention a concrete example where we have been using PS waste converted into monomer styrene. This monomer styrene has been converted into recycled polystyrene at our premises in Belgium. This polystyrene granulates has been transformed at Intraplas, a leading sheet converter, who has then sent these PS sheets to a food producer, Yoplait, who has been producing yogurt pots using 50% of certified recycled polystyrene as per the mass balance concept. This has been launched May 2021, and this is part today of a continuous production process. More brand owners to come by the end of this year to also launch their own dairy product using the same recycled, chemically recycled RPS. Next slide. So I will finish this story by emphasizing different elements. First of all, this circular journey has been a success thanks to the concerted effort of the whole value chain. This is about collaboration. Arthur mentioned it, collaboration, collaboration. And Yoplait, Intraplas, and Trinseo partnership is a good example of it. The other element I would like you to retain is, again, PS as a very simple chemistry. And this simple characteristic enables to do an effective recycling of this material. This material has been used for the last 17 years in food packaging. It's an ideal product which can be easily processed at lower temperatures than other material, which also is positive from a sustainability standpoint. again, we do have commercial product available. I mentioned chemically recycled RPS. This is available today. I mentioned the biopolystyrene from bio-waste. This is available today. I also mentioned the Lca analysis, which the consortium SCA has been generated, showing a reduction between 75 to 80% in terms of carbon emission, depending on the technology used. Last but not least, again, today, we can deliver this mass balance type of products, which avoid any retesting, requalification, no further capital investment. So today, any customer's brands can use recycled polystyrene, biopolystyrene to improve its carbon emission impact, notably their scope 3 emission. With that, I will end on that, and obviously welcoming any question that the audience may have. Thank you.
Julian, thank you very much. Another very interesting presentation. I think the first question then is, of course, across Europe, but certainly in the UK from next April, we are looking towards a plastic tax, £200 per tonne. So you mentioned that is food grade not been certified yet? And is that coming, and what time scale? Or can we already put the product into food grade polystyrene products?
Yeah. So we've got different options. So I mentioned the dissolution technology, which is not yet food approved. Now I do have the chemical recycle technology, which is food approved. The RPS that we can provide to the market today, which Yoplait is using, is totally food approved. And they are not using the 3-layer structure. This is food approved. And actually, the UK legislation is very interesting in the sense that this new tax actually is the first one to embrace chemical recycling and mass balance. So actually, there is solution today, RPS, which can address this 30% non-recycled plastic tax that will be implemented within 2022.
Thank you for clarifying that one. Thank you. And there has been a question through from Chris. I know you had a slide around the kind of the LCA comparison, which is an important part of the story. Just any further clarifications around comparisons between the 3 different systems shown in the LCA?
Yeah. First of all, the full LCA will be publicly available within a couple of months. This is now reviewed by external panel. That's one. Yeah, as you can see, the difference between the different technology are not so predominant. The main explanation I was mentioning comes from the yield. Super clean mechanical recycling, the yield of this process is lower than the other technologies, chemical recycling and dissolution. So that is one important driver, which does explain the reduce, I would say, the limited gap between the different technology, contrary to what probably our scientific intuition would tell us.
Lovely, thank you. We need to move on, but hopefully you can join us at the end for a short discussion. Thank you very much. Okay, we move on to our final speaker. We have Rick Hindley, Executive Director at Podback. And I was reading recently that Podback have reached a year, and I can't believe it's been a year since it was first set up, but very interested to hear about progress and future plans. Over to you, Rick.
Good morning, Stuart, and good morning, everybody. And thank you, Stuart and the team, for the invitation to talk this morning. For those of you who know me, my background is actually in aluminium, not in plastic. So I've learned a lot since joining Podback in May. And you may be pleased to hear that I'm not going to talk about the technical part of recycling pods, and my presentation definitely isn't as technical as those that have gone before. I'm going to talk specifically about collection of pods and really talk about how Podback is pioneering extended producer responsibility in the way that we're developing our systems to collect pods. So as a forerunner to what's coming with the new EPR plans for packaging, Podback has really taken that approach right from the very beginning. So I'm going to talk to you about recycling both aluminium and plastic pods, and as I say, focus very much on collection. But before we talk about the collection side, let's talk a bit about coffee pods and about Podback. So Becky, please move on. So what is Podback? So for those of you who are not familiar, there's just under 2 billion coffee pods and hot beverage pods sold annually in the UK. And as you can imagine, over the last 18 months or so, the sale of pods have skyrocketed, with people working at home, wanting to enjoy coffee and not miss out on the coffee that perhaps they bought on the way to work, or the fine quality coffee that they had at work. So just about 2 billion aluminium and plastic coffee pods sold every year. And Podback was formed, as Stuart said, almost exactly a year ago when it was first incorporated, and it was set up by the leaders in coffee pod manufacturing and sales. So that's Nestle, Jacobs Douwe Egberts and Nespresso. And together they have about an 80% share of the pod market in the UK. And they had been all working in their own way to collect pods. Nespresso was probably the most familiar recycling system, which was set up sort of 14 years ago. But they recognised, in order to really drive growth and to achieve their vision, they needed to work together and collaborate. So that they set up Podback as a pre-competitive organisation. And we aspire to represent all of the companies involved in putting coffee pods onto the UK market, whether that be pod manufacturers, retailers, etc., etc. So soon after our launch, formal launch in May this year, our first independent coffee pod brand came on board, Crew Cafe, and we're just on the edge of launch of announcing a number of new coffee pod producers and retailers joining Podback, and we're making those announcements in the next couple of months. So we've moved quite fast, but we aspire to be totally representative of the sector. And as I said at the beginning, we believe, pioneering extended producer responsibility, with our members taking their responsibilities seriously, and as you'll see, funding the expansion of our consumer-focused collection system. So Becky, move on, please. So very simply, we have one vision, and that's a world where every coffee pod enjoyed is recycled. So we aspire to maximize the recycling of both aluminium and plastic pods. Thank you. But we are faced with a challenge, and as I said, our founder members have been all involved in their own initiatives to collect pods. And what became very apparent is that there are some challenges that we face along the way. And it's not actually possible to collect pods mixed with your normal aluminium and plastic packaging. And the reason for that is both the size and the weight of the pods makes it very difficult, but fundamentally, at the end of their life, they still contain organic matter. They still contain the coffee that is retained within the pod. So clearly that has to be removed before they're recycled. But equally, in a normal sorting system where, as we know, packaging typically is collected mixed together with aluminium and plastic, and typically when they go into a MRF, into a sourcing centre, they go through a trommel, and those trommels have small holes in them, and the pods are so small that they typically will fall through the holes in the trommel, and so end up in the fines and not make it through the recycling process and end up in either the plastic or the aluminium streams. And so will eventually end up either going to landfill or being incinerated. So we've designed the Podback system to avoid that issue and to ensure that all of the pods that are recycled are collected actually end up in recycling. And so, as you'll see, we've developed a bag-based system where pods are collected in separate plastic or aluminium bags. And so, just moving on, Becky. So obviously, before we set up Podback and really developed our collection system, we wanted to understand what consumers thought and to design a system which was convenient and easy for them to use. Interestingly, as you would probably expect, around 2/3 of the people we spoke to were not actually aware that pods could actually be recycled in the first place. And so there was a job to do there to to assure them that if there were systems were in place, that all of the pods would actually be recycled. But what was really encouraging, that once we actually explained to them that pods could be recycled and that we were developing a collection system, 9 in 10, so 90% of the consumers we spoke to said that they would actually engage and that they would actually recycle the pods that they were using. And you'll see later on in the presentation that actually that's now proven true, where we've developed the collection systems where the participation rates are rapidly growing and demonstrating that give consumers the option and they will actually make that choice and become an active recycler. So we needed to recognize very early on that for this to work, we needed to be making pod recycling easy, as convenient as possible for consumers. So, hence, we have prioritized right from word go that pods should be collected at curbside, not together with, but alongside traditional packaging materials that are collected at curbside. So first and foremost, it's all about developing relationships and partnerships with local authorities. Becky, thank you. So right now we have two collection systems in place and a third which we're looking at developing. As I say, our priority is curbside collection. Consumers have 2 bags, a white bag for aluminium and a teal coloured bag, green coloured bag for plastic. And the way consumers find out how the system works for them in their area is that they go onto the Podback website, put in their postcode, and it will tell them whether their local authority already has a curbside collection system for pods. And if they're not in a curbside area, they will be directed to Collect Plus. And we've developed a relationship with Collect Plus, where again, consumers can order their bags. We send them the bags, or they can get bags through our members, who they're buying their coffee pods from. And they then take those bags to one of 6,500 Collect Plus drop-off points, and they can drop them off for collection. And that's all free of charge and funded by Podback. And the third collection system that we're looking at and talking to retailers about is actually what we're calling bring back. Hand over at home. So where you have your groceries dropped off, that you would then be able to put your pods out for collection at the same time that your new pods are delivered. But that is under development, something that we've not actually launched yet. So whatever the collection system is, the pods end up coming back through our systems to our recycling plants, and all of the logistics is managed by us as Podback and paid for by Podback and Podback members. So move on, Becky, please. So whatever the collection system that you use as a consumer, the pods then come back for recycling in the UK. So all of the pods collected are reprocessed in the UK. The aluminium pods go to Tandem in Congleton in Cheshire, where the pods are shredded, the coffee grounds removed, and the coffee is sent for anaerobic digestion, obviously to create energy, and then ultimately becomes a soil improver. And the plastic pods end up back in Manchester, a company called Royden Plastics, where again the coffee is recovered and the plastics are recycled. The aluminium is typically going into drinks cans, although it can end up in a variety of different aluminium products. The plastic pods are going into again a variety of different plastic products at the moment, but it's our ambition next year that they will go fully circular and back into food grade plastic, and a lot of work going on to make that become a reality early next year. So watch this space on that one. So move on, please. So local authorities, as I said, are key to us for making pod recycling as convenient as possible. And the good news for local authorities, if we've got any in the webinar today, is that it's actually cost neutral. So it doesn't cost local authorities anything to collect pods. So we've got 4 existing partnerships. We launched in Cheltenham and South Derbyshire at the beginning of the year, sort of April, May time. And then over the summer, we launched in Chichester and Oxford. And typically, we don't have one size fits all. We will work with the local authority to design a system that works for them. So if you take Cheltenham as an example, they have a curbside sort of vehicle. You can see there the Roma Quick vehicles, but they've also got residual waste collection vehicles, a typical RCV. So the RCVs we have fitted with cages, which you can see there under the vehicle, and the recycling operatives simply pick up the bags of pods, which are put out either on the day that your residual waste is collected or on the day your recycling is collected. On the residual day, they put them into the cages under the vehicles, and on the recycling day, they go into a specific part of the Recoup vehicle. In Chichester, as an example, we've put on a single pass vehicle there, which is funded by Podback. You see the picture of the van, and that actually collects textiles and wee at the same time as it's collecting its pods. So that's a model that we're also developing. So whatever the system a local authority operates, we will work with them, and we will pick up all the costs that they incur for collecting the pods, whether that be capital expenditure for a vehicle, or indeed to adapt an existing vehicle, operational costs for actually collecting the pods over and above their normal collection costs, and marketing communications costs. And I'll share with you a bit more about what we're doing there in terms of marketing communications. We were planning to have 6 more launched before the end of the year. All the contracts are signed, but unfortunately, due to the current challenges faced by local authorities, partly because of COVID, but also because of the driver shortage, all of those launches are being put on hold till the first quarter next year. And we're really encouraged by the fact that we've got discussions going on with local authorities across the UK, and we're confident that we'll be launching at least another 30 local authority partnerships next year, and with a view to having 150 in place within the next 3 years. So very ambitious plans, say fully funded by our members, so true extended producer responsibility. And the really good news is that those schemes that have been running already, so Cheltenham and South Derbyshire have been running the longest, the participation rates are beyond our expectations. So we are really seeing that consumers, where we offer the service, will engage and will use it. And we have participation rates of already of over or close to 50%. So 50% of people who have pod machines in those areas already using the scheme, which is really encouraging. So move on, please. So this is just a few more pictures of how it works. So you can see there the cages that we've fitted under RCVs. You see pictures of the pods being placed on bins out for collection. And then you see in the bottom left of the picture there, the pallet bins, which we put into the local authority depot. So very simple. They just put the plastic pods into one and the aluminium pods into the other. We provide 8 containers at a time. When they're approaching being full, they contact us, and we then organise for the pallet boxes to be picked up and taken for recycling. So very, very simple. See there also the picture of the Recoup vehicle with the pods actually being put into the same container as textiles in the Cheltenham case, but it does differ according to different local authorities. Next slide, please. Communications, really important for any recycling program, as we know. And from my experience at AluPro, where I was previously, where we ran the Metal Matters campaign, if your campaign looks different from any normal recycling campaign run by a local authority, it's got a better chance of being successful. So we have commissioned Get It Sorted, who are specialists in local authority recycling comms, to develop a leaflet campaign for us, because it's still, all the research shows that a leaflet to the household is the best way to engage people in a new recycling service. So we have a 12-week campaign where we launch a pod recycling initiative. It starts with the first leaflet, which is designed in the shape of a coffee pod, of a coffee cup. So this comes through your door. The second leaflet, delivered 8 weeks or so later, is in the shape of a coffee machine. And then the third leaflet is a thank you leaflet, thanking people for taking part, and just reminding them how it works. So this is all funded by Podback and managed and introduced by and deployed by Podback. So this actually wasn't in place when we launched Cheltenham and South Derbyshire. We're just about to go back there in the next couple of weeks in the run up to Christmas to remind people to recycle their pods at what's one of the peak consumption times for coffee pods, which is the Christmas period. We're really looking forward to a further increase in participation rates. So communication key, keep it simple, and we're also in the next couple of weeks launching our own digital channels for Podback as well, to further encourage people to engage over the Christmas period. Thank you, Becky. Move on. So finally, from a local authority perspective, why should local authorities get involved? But equally, for companies that are putting pods onto the market, they have a responsibility to get involved and to encourage us to make pod recycling as easy as possible. But fundamentally, it's cost neutral to local authorities. We pay all of the costs, true extended producer responsibility. For local authorities that are worried about what's coming along the way with EPR, it gives them an opportunity to put their toe in the water and find out how it could work and how measurement and funding will work or could work. So Podback, obviously pods are a very small waste stream, but equally a lot can be learned from it in terms of how the systems will work going forward in the future. Adding new materials to existing recycling schemes is always a positive. It gives an opportunity to boost awareness and typically will result in not just an increase in the collection of pods, but equally other materials through increased communication. Demonstrates a commitment to find and bring solutions to householders for collecting hard to recycle materials. And although, as I say, pods are a small fraction, it does make a positive impact to reducing carbon emissions and carbon savings. So all good positive reasons for getting involved in pod recycling. And I think that was my final slide. So yeah, just a thank you to you for you listening today. So whether you're involved in pods in any way, we'd be delighted to talk to you and tell you more about how you can become involved in Podback. And as I say, we've got big plans for next year. Lots of exciting announcements coming in a couple of weeks before Christmas about new members and new collection opportunities. And just finally to say that whilst my presentation is focused on consumer collection, we're also developing a B2B solution which will be launched next year. So a lot of pods used in businesses, whether they be hotels or offices, and next year we'll be launching a collection system for them as well. Thank you, Stuart.
Lovely, thank you, Rick. I've got some quick fire questions to start with. If you can just clarify who Collect Plus are and whether this is an England or a UK-wide scheme.
So this is a UK-wide scheme. Collect Plus is run by Yodel, the delivery company, and yeah, they've got 6,500 drop-off points across the UK, typically newsagents, petrol stations, things like that. So go on the Podback website and you can find out how that works.
Okay, and just to check, you are open to approaches from local authorities. It sounds like you've got quite a lot of interest, but you're still open to hear from others that want to engage.
Absolutely, yeah. So we've got a lot of interest, progressing a lot of schemes next year, not just with individual local authorities, but with a multitude of local authorities. So partnership areas, counties, and thanks to you guys at Recoup for an introduction to one of the big local sort of counties in the UK who's really active. We've got hopefully a scheme running across that area as well. So no, definitely open to as many local authorities as we can talk to. Okay.
And in terms of looking beyond the pod, you mentioned some of these schemes, maybe looking at textiles, and so on. There is quite a bit of plastic packaging that falls into that small category that does have issues getting through the system. I mean, how much wider could it go? Is it potentially going to become much more than just Podback, or given the sponsors and the direction, do each of the different areas maybe need separate Podback type style schemes, do you think?
Well, I think that's a really good question, Stuart. Clearly Podback is focused on pods, but you're quite right, our members are involved in other areas, and we are already in discussions with other sectors about collaborations, because if you take the Chichester example, which is effectively a single pass vehicle, it makes sense to be collecting more than just pods. So as you'll see there, we're collecting and textiles, but batteries is also on our radar. We're launching a couple of schemes next year in major urban areas where we're talking about partnering with, again, a single pass vehicle, but collecting other difficult to collect or difficult to recycle materials. So we see Podback as pioneering this, but definitely open for partnership. I mean, it makes sense both in terms for consumers that they're putting out more than just pods, but equally, this is obviously not cheap to do, and so there's an opportunity to share costs so to make it more cost effective and maximize collections. So no, we're open to discussions on all of these things.
Fantastic. And finally, if I can have a 2-sentence answer to a 2-part question, what polymers are used to make the plastic pods, and some we think are made from compostable plastic, so are they included and do they cause an issue for recycling?
So probably, Stuart, you can answer your own question better than me. As I said at the beginning, I'm not a plastics expert, but as I understand it, the majority of the pods are polypropylene. On the compostable question, our members don't actually produce compostable pods. Their view is that the plastic and the aluminium pods provide a more sustainable solution. So Podback isn't involved in the collection of compostable pods, and we're concerned that if we did get involved in that, it potentially would contaminate the other pods from a recycling point of view. So yeah, compostable isn't within Podback's remit.
Lovely, thank you. So if I could ask the other speakers just to switch the cameras and mics back on. Thank you very much for that, Rick. Whether it was chairman's prerogative or just poor chairmanship, we actually have run to 5 minutes left, but we've got a lot of the questions out the way as we've gone along. So for me, actually, we're in a position where there is a key question that's hovering around, and that is, you know, the complex products, materials, they're there for a reason, for function, but the question seems to be around, we're looking to develop solutions. What if redesign comes along and removes that complexity? So what's the balance between redesign versus the technical solutions? And I think it's a key one for quite a few areas. So Arthur, do you want to get started on that one?
Thanks for that, Stuart. Any more hospital passes, please feel free to pass to the other contenders. The key, yes, the key thing is that I think there's a balance to be struck between racing off and inventing a whole load of new solutions versus looking at what we currently have and trying to recycle what we currently see in use. I think Julian alluded to it as well, and also the question about the pods themselves being made of some biocompostable material. Not that that's not a noble issue, but the fact that it then makes a complex problem of the waste handling of it, perhaps. So I firmly believe we're at the beginning, or we're only scratching the surface. Look at the tonnage that Julian alluded to. That was a great talk, by the way, Julian. And the amount of tonnage is small, but you can see that already, not small, but it's part of a bigger picture of polyolefin resource that could be recycled. It's also a nice solution to take it back to the original material as well, I think. So if you're asking me for a direct answer is, I think we should look at what we currently have, reduce the use of it, obviously, and try to recycle as much, or look for solutions of what we can do with what we currently got, and not race off to create a whole new load of polymers that may make a complex mess of recycling. I think my last point on that is, if you haven't got infrastructure, which is very ably made by Rick, if you haven't got the infrastructure to collect the stuff, you're not going to be able to recycle it. And I think his talk was, all the speakers were good, I agree, but I think that really highlighted that aspect.
Julian, I'm assuming, you know, styrene, polystyrene is quite hotly debated around single use and discussions at the moment, but you're clearly telling us from your presentation, styrene has a role to play, there's environmental benefits, but that technology development, then you think the timescales can fit, and it is definitely worth pursuing technical solutions and growing that infrastructure.
Again, I mean, the narrative around polystyrene has changed significantly over the past 2 years. I mean, I would like to mention probably an anecdote. We are discussing with Ellen MacArthur, this very influential NGO today in the plastic arena, asking basically how did we come to some kind of recommendation to take away polystyrene in their charter. It was done in 2017, and basically at that time they did ask their signatories what were the plastics which were difficult to be recycled. And yes, polystyrene was part of them, in the sense that a few years ago, this material was recycled to a certain quality, which was not enabling it to find some good outlets. So it was going into clothes hangers, flower pot, etc., rather low value type of application. Today, thanks to the, several drivers, customer awareness, brand pledges, regulation, which is probably the predominant drivers, there is an acceleration of the technological development. And today, this technology, chemical recycling, superclean mechanical recycling, does allow to bring high quality recyclates and opening new realms, new markets. And obviously, for all the stakeholders on the recycling chain, PS now could become very interesting material to get recycled, because it can generate value for each stakeholder along this value chain, which was not the case a few years ago. So over the past 2 years, there has been a dramatic change in terms of adding new initiatives to make this material high quality recycled. But there is still some way to walk. We have been able to take on board important stakeholders like Yoplait. Very soon, other brands will join, but this is not ending. We still have quite some work to do to make sure that this material will be kept and considered as it should, which is probably one of the leading circular material.
And John, isn't that right also for the workwear, in terms of, you mentioned, some of the challenges you face is because of the different materials that are used? How much do you think redesign might play a role in helping you achieve what you're trying to achieve?
Well, in fact, part of what we're doing is helping with that simplification, through challenge, really, I suppose. So, for my sort of space at the moment, our focus is on the polyester, which is the sort of the key functionality, if you like. That's the carrier of safety or performance, depending on what product you're looking at, whether it's to keep you dry and warm or keep you safe, or both. But it's some of the bells and whistles, I think, that are the tricky components. So, what's the zip made of? What's it stitched together with? The toggles on the end of the little bit of rope that's stuck in around the hood, and then there's the backing of the high visibility strips. So, again, really important functionality. How can we simplify the product, but not in any way erode its performance? Can we improve the performance? Can we improve longevity so it's in flight for longer, which I think is a challenge for, particularly for FMCG space. That's a whole nother story. That's really about moving to service from products, and that whole kind of piece that comes with that in terms of the service. But how can you improve that longevity, that in-flight piece, so it doesn't become suboptimal? It still performs, and all of that is about improving not just the products, but the way it performs, the function it performs. So I don't see it as a massive, I only see it as a positive, thing that needs to be part of what we're doing. I don't think we are going down a technical sort of wormhole, if you like. I think there's other questions for sure in terms of, what are we going to end up with in terms of products, and therefore carriers of those of those products when we move to service. But we're still going to have stuff with things in it, or stuff that we wear for quite a long time, and there's a lot of stuff in flight, remember, as well, that needs to be managed. So I think that would be my answer to that one, Stuart.
Okay. And Rick, I'm guessing it's simpler for you in terms of, if the popularity of the coffee pods continues, they need to be the size they are, and the product is the product. So I'm guessing you've got no choice but to provide that technical solution.
Absolutely correct, Stuart. I think people ask the question, well, can you do anything to the pods? Well, I think the reality is the machines are the machines, and you can't change the design of the machines. They evolve. Clearly, Nespresso have evolved their pod and their machines. And I think the simple answer is that both the aluminium and the plastic pods are recyclable. Yes, the plastic ones we can do better, and that's what we're going to be doing next year. So moving to hopefully a food grade solution. But I do fear that if you look at other alternatives, it does or can create problems with the existing systems that we've set up. Hence my comment about the cost compostable solution, which potentially will contaminate or could contaminate the plastic pods, and indeed not so much a problem with the aluminium ones, but if they get into the plastic stream, it's a problem. So yeah, let's stick with what we've got from a pod point of view. We've got solutions that ensure they're recyclable. For us, it's all about collection and getting as many back as possible, because then it becomes really efficient and the investment. And what I should also add is that the bags that we use are also recycled, so they are recycled in the same location. So that's a positive as well.
Okay, we need to finish. We could quite easily carry on for a long time because these are all very interesting topics. So thank you to Rick, to John, to Julian, to Arthur. The presentations were great, and we did spend a bit more time on the specific questions because we are looking at complex areas and challenges. But you know what? It is a little bit sciencey. Anyone can draw a wheel. But I think this just goes to show you this morning that there's a lot of development happening. Things are moving fast in some areas. Personally, you know, I see the collection and sorting as a science in itself to get right. And for every time that a speaker mentioned challenge or difficult this morning, it was pretty swiftly followed up with where the solutions are either possible or developing or actually in place. So hopefully that gives faith that we are moving in the right direction as a sector. But there'll be a lot more to come. So thank you to those who've tuned in today. You've been listening to the Recoup webinar. Just a final comment again, we do have tomorrow the launch of the Recoup 2021 Household Collection Survey. So please do register and tune in for that. And on Thursday, we're covering off another interesting topic, which is film recycling supply chain opportunities. So thank you once again, and goodbye from me.
Thank you, Stuart. Thank you all.
Thanks all.
Thank you. Bye, everybody. Nice to meet you.